Hello everyone, and welcome to a basic lecture on hypothesis testing in statistics. In this talk, I will teach you how to use hypothesis testing to answer problems in the world. For example, does the battery actually work as well as the manufacturer claims? Or whether newer drugs are actually more effective than older drugs? Or there are any differences in chocolate preferences between boys and girls? In fact, hypothesis testing is a very powerful tool that can help us use a sample data to infer the situation of a parent parameter. I will take you through the concept of hypothesis testing, the steps to perform it, what assumptions it makes and how to interpret it, and what errors can occur. I hope you all enjoyed this presentation. First, let's talk about what a hypothesis is. In fact, it is an educated guess about a parent parameter or the relationship between them. The so-called parameter is a numerical characteristic about its parent, such as mean, proportion or standard deviation, etc. For example, you can have a hypothesis that the average height of a class is 170 centimeters, or that the proportion of girls in a class is 60%. In fact, our hypotheses can be formed based on previous data, theoretical models, or practical considerations. Then, our hypotheses will be tested using sample data or statistical methods. But how exactly can we test these hypotheses? How do we know if our guess is right or wrong? We're going to keep watching. Next, I will talk about what a hypothesis test is. In fact, a hypothesis test is a procedure that uses sample data to evaluate a hypothesis. In fact, a hypothesis test involves two mutually exclusive hypotheses. One is the null hypothesis, and the other is the opposing hypothesis. The null hypothesis, which we will use H0 to represent, is a hypothesis about the current situation or a fact, and we will first assume that it is true, unless we have enough evidence to argue against it. To put it simply, it is usually some historical data, some people's claims or some product specifications. So, we want to challenge or test it. Relatively speaking, we will use H0H1 to express the opposing hypothesis. It is the exact opposite statement from the null hypothesis. We just want to find enough evidence to support it. For example, an example is the null hypothesis that the average height of a class of students is 170 centimeters. The alternative hypothesis could be that their average height is not 170 centimeters, or greater than 170 centimeters, or less than 170 centimeters. It depends on the problem you want to study. Therefore, the opposing hypothesis reflects our doubts about this matrix parameter, or whether you believe it or not. Okay, let's look at an example that we'll use next. Suppose there is a manufacturer who claims that for their battery STA101, its average life is 500 days. As for the standard deviation, it is 25 days. You are now the buyer of these batteries and you feel this claim is exaggerated. So, we want to test your claim because you can't terminate the contract if you don't have a good reason. So, let's take a look at the steps. The first step is to clearly define this random variable in this parameter in words. The first step is that we first clearly define the random variables in parameters in words. The random variable is x, which is the life of this old battery. As for mu, it is its average life. Then we need to clearly state the null hypothesis and alternative hypothesis. Null hypothesis means that H0 is mu, which is really equal to 500 days, because this is what the manufacturer said. Then alternative hypothesis means that mu is less than 500 days, because we suspect that its average lifespan is not even 500 days. So, how can we decide which hypothesis is more likely to be correct? How can we weigh for or against this null hypothesis? Let's just keep reading. Okay, next I will talk about how to conduct this hypothesis test. In fact, we generally have 6 steps to do it. The first one is to clearly describe the random variables in parameters in words. The next step is to explain null hypothesis and alternative hypothesis in the significance level that will be discussed later. Then we will state and check the hypotheses of this hypothesis test. Then we will calculate the sample statistic test statistic in p-value, which will be discussed later. Finally, we will draw a conclusion. Based on the p-value and significance level, we will decide whether to reject H0 or not reject it. At the same time, the reasons must be stated. The final step is to provide an explanation. We need to explain the practical significance of this conclusion based on the background of the problem. Okay, let's talk about the assumptions of this hypothesis test. In fact, every hypothesis test has some assumptions that we need to meet. But this ensures that its results are valid. In fact, it depends on the type we want to detect, the number of samples, and what are the different types of parameters. Often these assumptions will be made about the sampling method, or sample size, or it's the distribution of the mother body. But this must be clearly stated before we conduct the test. In testing these hypotheses, usually our common assumption is random sampling, normal distribution, independence, and having a sufficiently large sample size. Next, let's use the same example again to see what are our common assumptions. But this one is actually a single sample z-test. It's about detecting the average value. Then we will have the following hypothesis. The first one is to find such a large random sample in the matrix of interest. Then the most important thing is this, the matrix standard deviation. The sigma is known, so that the z-test can be used. And then we have to make sure that the sample size is at least 30. Or the matrix of this random variable itself is normally distributed. So how can we check these assumptions? Well, the first one you can actually take a look at how this sample was collected. But then the second time you can look at the information given to you by the manufacturer. And then the third one is you can look at the sample size. Or is the shape of your sample distribution so that it can be detected. Then if these assumptions are met, we can proceed to the next step. If not, we may have to choose another detection method, or adjust your test statistics. So what should I talk about next? It is this test statistic in this p-value. So in fact, this test statistic is a standardized value. It is used to measure this sample statistic in this null hypothesis value. What's the distance in the middle? So that's how much water you are talking about. So actually it depends on the type of hypothesis test. The number of samples is somewhat different from the type of parameter. So in fact, usually we assume that the null hypothesis is correct. Well, in fact, this test statistic usually follows a known distribution. Then it will usually be normal, or t-distribution, or something else. So taking the example just now, this time it is a z-test of one sample. And you are calculating the mean. Okay, then the next step is the p-value. Okay, let's follow this up with a p-value. So it actually assumes that this null hypothesis is true. After all, this test statistic is so extreme, or how much more extreme possibility there is. So actually, our p-value will depend on the test statistic that I will talk about later. Its distribution, and this is the direction of this alternative hypothesis. Because this is a stipulation, first of all, it is too small, too big, or not equal. So actually, the test statistic and the p-value can be calculated through formula tables. Or it can be calculated using a computer technology counting machine. So we are left wondering what their significance is or how they can help me make a decision. Okay, so we're back to this example again. This time we will make it clear that there are 30 samples, and their sample mean is 490. So what is the relationship between a test statistic and a p-value in this hypothesis? Okay, so actually, it is a one-sample z-test for the mean. So the formula for our test statistic will be this x bar mu 0. Z over run sigma over root n idiographic period. So actually, the degree x bar is the sample mean, mu is the number of null hypotheses. Then sigma is the maternal standard deviation, and is your sample size. So after you put the numbers back in, we can calculate this z, which is probably equal to negative 2.19. So as for the alternative hypothesis, we have decided it to be, mu is smaller than 500. So this one is a left-tailed test. So actually this p-value is what we will use to make the next decision. Just use a standard normal curve to calculate the area on the left side. It is a much smaller opportunity than z equals minus 2.19. Its p probability, then it will be 0.0142. What does it represent? In this picture, you see a standard normal curve. So I will have to look back at our test statistic z. Just minus 2.19, which is what this red straight line shows. So as for the shaded area on the left, it is actually what happens to the p-value. The probability is 0.0142. So it means that under the condition that the maternal average is 500 days. Then you will have a 1.42% chance, when the sample mean is smaller than 490. So it is quite small. So we can deduce that the assumption that the population average is 500 days may be wrong. So the question is, what should I do first? How do we decide? Okay, so how do we come to a conclusion and explanation? Okay, so actually our conclusion is based on the p-value in the significance level. We reject the null hypothesis. We use alpha to express the significance level. It is a probability to be decided in advance. That's what we are willing to accept to have the maximum chance of a type 1 error. Is this a type 1 error? It was when the null hypothesis was right that we mistakenly rejected it. This is a type 1 error. So what about the rules for making this conclusion so sorry? In fact, we usually use 0.01, 0.05 or 0.1 for this point. Then the rule for us to make this conclusion is, if this p-value is smaller than alpha, we will reject h0. This means that we have enough data and enough evidence to prove our alternative hypothesis. So the reverse is true, if it is greater than equal to alpha, we don't have to reject h0. So we don't have enough evidence to prove our alternative hypothesis. So remember to make it clear that you are using a p-value in an alpha. This explanation is to remind everyone to use human words to explain clearly what your conclusion means. This will answer your original research question. So remember to use words, not numbers, for the data you first researched. So remember to clearly explain what statistical significance and practical significance are. So statistical is purely about the probability of something happening, but then practical is about what its actual meaning or use is in the real world. Then when we explain, we must also remember to admit that it is possible to count the wrong number or make the wrong decision. Because in addition to the type 1 error just mentioned, there is another type called type 2 error. Type 1 error I just mentioned, type 2 error means that when our null hypothesis is wrong, we did not reject it. This is type 2 error. Then we mistakenly left the null hypothesis that should be rejected. Then we will call this beta, which is usually difficult to calculate because we don't know. Then on the contrary, we have a power that is when the null hypothesis is wrong, we correctly reject it, thus doing the right thing. Well, this power is 1 minus beta. Of course we think the higher the better. However, this page also reminds everyone that there must be a trade-off between type 1 and type 2 errors. If you want one to have fewer errors, the other will have more errors. Unless you can increase the sample size, or you change your test. Well, when you choose alpha and sample size, you have to consider the consequences. Because this will affect the feasibility of the data you collect. Finally, let's use this example to talk about how to draw conclusions and explanations. So, the answer is that we have calculated the test statistic at the beginning to be minus 2.19, and as for the p-value, it is 0.0142. Then, the significance level chosen for this question is 0.1. Then, our conclusion is that because the p-value is less than 0.1, we will reject the null hypothesis. Moreover, we will have enough evidence to support our alternative hypothesis, that is, the average lifespan is less than 500 days. This means that the manufacturer's claim of an average lifespan of 500 days is very likely wrong. Then, we have a good reason not to sign him. Okay, finally, this hypothesis testing is a very important statistical tool. Because it can help us use some sample data to infer the overall situation. So, today we learned the basic steps of doing a hypothesis test. Then, we will discuss each step in more depth in the following classes. In what different types of testing can be done. Okay, this is the end of my class today. So, I hope you all learned something useful and practical. Also, thank you all for participating.